In this lesson, we are going to learn how to determine the stability of a system once we know the poles and zeros. In the previous lesson, we have already learned how to find the poles and zeros, and we have seen in general the pole and the zero can be a complex number. Okay, a complex number means it's basically in this format. It has a real part and an imaginary part. Okay, we have also seen how to plot it in the complex plane. To determine the stability, we only need to look at the poles. We don't need to care about the zeros. And if all the poles are located on the right hand side of the plane, if all the poles are located on the left hand side of the plane, which means on this side, then the system is stable. Okay, so how we know everything is here? All the crosses must be here. There shouldn't be any crosses over here. Or you can look at the value of the poles. In the poles, all the real part of the poles, okay, this one, all the real parts should be negative. Then the system is stable. If any of the pole is on the right hand side, okay, for example, this plot, we have one cross over here. Or if you look at all the poles, if any of them has a real part, this one, which is more than 0, which is positive, then the system is unstable. Okay, as long as one is positive, it's unstable. Okay, then we have marginally stable. If the poles is a complex conjugate, which means the real part is 0, there's no real part, only the imaginary part, only this, then we say the system is marginally stable. Now let's look at the example from the previous lesson. This one, is it stable or unstable? If you look at the plane, we can immediately see all the poles on the left hand side, which means the system is stable. Okay, all the poles are here. You can also see at the pole values, okay, the S value, all the real parts are negative. Okay, if all the real parts are negative, then it is stable. Okay, if any one of them are positive, then you'll have a cross this side and it will become unstable. Okay, this is the answer over here. The system is stable. We can also see how the time response looks for stable, marginally stable, and unstable. Okay, stable is when all the poles are here. We can see the value eventually converges to 0. Okay, for stable. For unstable, it diverges. It just explodes to infinity. Marginally stable is somewhere here. It it oscillates. Okay, so that is the difference. That's all. Thank you.